Hi and welcome to a brand new video. In this video, I'm going to try to convince you why calculus isn't as hard as you make it seem. Lots of the time, people are intimidated before going into calculus, and that intimidation makes calculus hard for them. But in reality, it's just using basic algebra concepts in new ways. I'm going to try to convince you of this with talking about limits, which is about 1/4 of a calculus course year. So if you have, for example, a simple graph, and I'm just going to make this graph have a downward parabola, and we're going to name this f of x. I'm going to select this point, and we're going to assume that this is 3, 4. So that means this x value here is 3, and this y value is 4. Essentially, what a limit is that let's say that we have two lines on either side of this x value. As we bring them closer and closer together, what value does f of x approach? So since every x has a respective f of x, as we bring these two lines together, we're essentially asking what does the y value approach? Or as we get closer and closer to a specific point, what does f of x equal? So as we approach an x value, what does f of x equal? Boom. Really straightforward. That is what a limit is. So in this problem, you can kind of see that if we do that, we just approach this point. So what we can say is that the limit as x approaches 3 of f of x is just equal to 4. So this is the notation of a limit, where this part declares the fact that it's a limit. This part here talks about the x value we are approaching. This is the function, and this is the resulting y value, or what does f of x equal? So in this problem, as you can see, as x approaches 3, f of x is equal to 4. Now you might be wondering, why do we have a limit if we're just basically just saying what the value is at x equals a? In this example, why didn't, if the limit as x approaches 3 of f of x is equal to 4, why didn't we just use f of 3? Well, this is where it gets a tiny bit more complicated, but not really. Let's say that there is a hole at this point. That is a humongous hole, but we will deal with it. And let's say this point was defined somewhere else, or it doesn't have to be defined at all, but I'm just going to put that there. So let's say that now the hole is at 3 equals 4, but the actual point itself is at 3, negative 2. So f of 3 would be equal to negative 2, but the limit is still 4. The reason is because if we draw our two lines on either side of the point, as these become closer and closer together, the value as x equals 3 approaches 4. It's not equal to 4, but as these become infinitely closer to this hole, it seems like the value of f of 3 will equal 4. This is why this point does not even need to be defined, because it's just what the graph approaches as we get closer to a point, not what the value is at that point. So this is basically what limits are. You covered about a quarter of calculus in just 5 minutes. What if you have something like this where you don't have the graph? Well, this is easy enough to graph, but I still want to explain to you how you can solve this without graphing. What you can do is that, well, if you did have a graph, something like this is definitely not accurate, but as we approach a value of 3, unless this point has a hole, it is a value at this point. What I'm basically saying is that if no hole and defined, then f of the limit as x approaches a of f of x should just be equal to f of a because it's part of this function. Something to make this a bit more clear is that if you've used the words continuous or discontinuous, what you can basically say is that if f of x is continuous at x equals a, then this is true. This is a lot more simpler because it includes all the test cases in which this is true or false. So if you know what continuous means, I definitely recommend that you use that instead. So we know that this linear equation is always defined because it's just a line. So we can just substitute it into f of x. And there we go. The limit as x approaches 3 is just 2. So that is basically a lot of what you're going to be covering in limits. Obviously, there is a bit more, and it is going to be dealing with lots of practice problems, especially with possibly harder functions. However, this is the basic concept of it, and as you can see, it's not really as complicated as you might think it is. So I definitely recommend as you're going into calculus, just make it seem like it's easy. Think that you can do it and you've got calculus, and then you will.